Is responsible for roadmap definition, strategy, and R&D activities in Adeia's Media CTO office. Prior to Adeia, DJ was Senior Director for Emerging Technologies and Platforms at Charter Communications, where he built an R&D team focused on network-powered gaming, AR/VR, holographic light field communication, and ML/AI applied to quality of experience delivery on the network. So without further ado, DJ, take it away.
Thank you, Melissa. So thank you for being here for the absolute tail end talk of the enterprise track. I'm very happy to be here. I think my big takeaway from AWE is that the metaverse now has a definition. You might know that. I actually looked it up, that the XR Safety Initiative has actually provided an elegant definition of the metaverse. And normally I would have called this talk with the M word all over it, but depending on who you interact with, the M word is a dirty word, and it's all about generative AI and large language models, and what anyways is the metaverse, right? So that's why having an elegant definition to the metaverse is so important to me, right? Anyway, so Adeia, thanks Melissa for the introduction. Adeia, we are an R&D house. We look out maybe 5-10 years into the future, and then we try to define high-value use cases. And then we work backwards from there. What are the problems? So hopefully through this talk, my goal is to make you think about some of the problems that are on the horizon if the metaverse, when the metaverse matures, when the metaverse scales. So what am I going to be talking about today? So the talk will largely focus on server allocation for social worlds or metaverse, right? So that is actually a big problem today because essentially it's related to scaling or lack thereof. And I'm going to take maybe two approaches at the same problem, one of which is a use case in which we are all looking for fruitful social interaction in the metaverse, VR chat, Horizon Worlds, what have you. And another one in which we are actually looking to do trading in the metaverse. And that is a use case that we also hope will develop. So just a quick introduction to what the problem is. So you have multiple, at least two main strains of multi-server architectures that happen in server allocation. When I go join Decentraland, when I go join Roblox even, right, I get allocated to a server. Now, if I join that server with a friend, join with a convoy, or I go join a live event on, let's say, WaveXR, and I have an invitation-only event, then I basically may see a few people that I know. But hey, if I join in at random, then I may not see anybody I know. And I may have this weird conversation with my friend, but hey, you're here and I'm here, but we don't see each other. Why is that? And that's because you are on two entirely different servers. Why does that occur? Because sharding is the primary architecture used today in server allocation and in creating servers. So what is sharding? You basically take your entire world and you recreate it on a server, and then you add users to it. So depending on who comes in, when, based on quality of experience, other policies, somebody walks in and is allocated a server. Another person walks in who was your friend, but you didn't join with them, and then they get allocated to a different server. So now you don't see each other. So the only way around that is that you go actually physically join, or I should say virtually join with a friend, right? And that's not very easy to do. And so we talk about how can we build those communities. So the long-term implications of this is that you will continue to have these disconnected experiences in virtual worlds unless this problem is solved better, right? So that brings me to a problem statement. So we know that we have many motivations for joining virtual worlds. You are looking for your tribe, you have experiences, interests, potentially trading in future, and we've all done some lurking in the past to figure out how these worlds work, right? So the goal is to define a healthy virtual community. How do you do that? Like, I make a reference, this is kind of the hypothesis of some of this work that we did, which is that humans work on the referral system. If you have a friend, then yes, you know that person, but you're more likely to speak to or interact with a friend of a friend or a friend of a friend of a friend, right? And that is how the community grows. And so it's kind of like that graph on the left side where you have each person has 2 friends, to a highly connected graph on the right side where each person gets to know each other. And that's where critical mass is attained and everybody benefits from that community. So how do you actually do that? And especially in the context of the problem I just described, where you have this sharded multi-server architecture. So like I said, the hypothesis is we want to facilitate what are serendipitous interactions. So the idea is that you choose a server. When I want to join, then I choose a server that maximizes the number of users that are at most n hops away from me in a friendship graph, in my online friendship graph. Which is to say that I join a server where I have friends of friends, friends of friends of friends, or what have you, right? So that is the fundamental sort of insight on the basis of which we think people should be assigned to servers. And if you start doing this, there are some corollaries. First is you don't need to join with friends. You don't need to look out and say, hey, I need to join with this person. I got to wait for him, got to communicate out of band with this person, and then jump in with this person so that I can actually see this person when I join. The second corollary of this is you keep doing this. If you think about user 1, user 2, and then by sort of the principle of induction, if you do this, then you will always have on each server a highly densely connected graph, people who kind of sort of know each other or are getting to know each other through serendipitous interactions. So, so this slide is a little bit of math, but I don't intend to go through it. I think the fundamental principle here is that you can make this happen using a breadth-first search with a depth counter, right? So you basically go and count. You take a new temporary user, you add them to every single server temporarily. You calculate where they can maximize the number of users on their online friendship graph that are at most n hops away, and then you remove them from all the other servers, and then you add them permanently to this particular server. And so, you keep building your community that way, right? And of course, it's useless without a user manifestation. So I basically took a shot of VR chat with apologies to them and credit to them, and I kind of created, my own geeky way of saying that, hey, in future, you jump in, you're not just seeing people's online IDs hovering over their heads, you're actually even seeing how they are connected to you, which then facilitates these interactions. So taking it a little bit further, friendships are temporal in nature. Friendships are not static entities. So I want you to think about that a little bit. Like, you have a rich metaverse, you have lots of data, you know how people are interacting. So friendships need renewal. They need more interactions, they need more positive interactions. So the idea here is that friendships must go through renewal. And they are basically decaying entities until they go through renewal, right? I talk to you frequently, infrequently, at one point in time, I talked to you 6 months ago. It looked great. We were like the best of friends. And then over a period of time, the friendship aged, and I never talked to you again, right? So I think this is the nature of friendships. So, we model this thing called a friendship intensity. So this is now the more time-varying model version of the previous static solution. Here, the friendship intensity is basically something between 0 and unity. And when you're strong friends with somebody, you are at your unity. When you are not a friend to somebody, your intensity there is 0. And a simple corollary of that, which we actually end up using in the graph theoretic work related to this, is you take a reciprocal of the friendship intensity, and that's a cost, right? So for example, the reciprocal of 1 is 1, so my cost to reach a friend is minimal, it's 1. But the reciprocal of 1 by 64 is 64. So that is not a very strong friendship, let's just say that, right? And then, as that particular node, that edge between two nodes, keeps aging, then your friendship, the cost is moving towards infinity, just as the friendship intensity is moving towards 0, right? So here's an example, right? I have a friend. The system determined through all of the levers that it has, interaction time, interaction frequency, positivity, and so on and so forth, that I'm very good friends to this person, and the renewal starts happening, and it starts decaying, and then the renewal happens, and then it starts decaying again. And so how do you solve for this? This also draws from methods that we previously talked about in the static model, except it benefits from a lot of the graph theoretic approaches that I just mentioned, such as Dijkstra's, Bellman, Ford, et cetera. You model this as costs. You add those nodes temporarily to every single server. You determine what is the server that maximizes the number of connected nodes or people, provided that the maximum cost is below a certain threshold. And once you do that, then you can once again find that server for you where you have the most number of friends, friends of friends, so on and so forth. So now let's talk about a slightly different problem statement where you are trading in the metaverse. I think this is important. We all understand that we want the metaverse to go this way. Digital goods, NFTs, they're essentially status symbols, self-expressive symbols inside of the metaverse, of our avatars, right? And also, they don't necessarily need to exist only in the virtual world. We understand that today companies are already experimenting with this idea that there's a real world asset, it's also an NFT. So, benefits that accrue in the virtual world can be extended to the real world and vice versa, right? So physical NFTs is, in my understanding, pretty much the same thing. Digital twins is something, I guess they use more in the enterprise world to describe something similar, more in the context of complex models and such. So anyway, here to the right, what you see is, an attempt at presenting what a user interface could look like. I come face to face with somebody in the metaverse. So first thing we need to do is we need to be able to present our digital goods ownership to each other, to the extent that we consent to that, of course. But I think that is one direction that the metaverse needs to go in. But then, again, that creates an interesting horizon of problems and solutions. So going back to the previous idea, now you have a metaverse, people trade in that metaverse. How do you make sure that you once again facilitate those interactions that matter in trade? So, I take NFTs as just a way of describing digital goods. There are probably going to be more models that are going to come up, but NFT is a pretty darn good model right now to talk about this. So now we need to match people. If digital goods represent your interests, it represents yourself in some way, shape, or form, then we need to represent that as an inventory to a server. And so what happens is that our goal changes to maximizing the match between a new user who wants to join the metaverse and the inventory of NFTs that already exists on that server through the people that are already present on that server, because then that maximizes the ability to trade. And so here's just one sample taxonomy to show that how, this is just a tree taxonomy to show how we would maybe express digital goods or classify digital goods. And so then you try to find the server which has the best match based on this taxonomy. Here's an example, again, method, but just a little geeky math. But the basic idea is that there's a figure of merit, and you figure out when a new user joins, you figure out, okay, here's an inventory of NFTs on an existing online server, and here's a multitude of servers like that. Now, when this new user joins, where does this new user's digital ownership match best across all the different servers? And so that is, again, is the insight behind designing a scheme such that users with interests, users who want to trade, can come together. Some other related issues, if you start thinking about NFT trade. I think we all know and understand that ultimately we want to be able to do this directly from the 3D world. I don't know how many of you have bought and sold NFTs. It's kind of complicated, right? And you go into OpenSea and you get all these public wallet, private wallet, MetaMask, you go through a bunch of hoops to try and get a simple trade done. So the idea is that we should be able to directly trade between a buyer and a seller with a social interaction. You first interact socially, and then you're able to take that forward through a set of APIs between the marketplace and the 3D world so that the right amount of monies can be deducted from the appropriate wallets and the digital good can be passed to the buyer. And another thought related to that is the idea of a delegate. In future, we would like to be able to, a seller should be able to delegate some portion of their digital goods to another person who can then act as an agent for them, right? All of these interactions are things that mirror how we behave in real life, IRL, and transfer to the URL, right? Again, other ideas very much related to that. So if you did all of this, you still need stronger and stronger manifestations in the UX. So, okay, you added people to a bunch of servers, you ensured there was match. Now, you got to do more things here. You got to bring up to different users that, hey, here's another person who has has a very strong match with you based on their digital user goods ownership, and so on and so forth. And also, we all know that Web3 has had a significant amount of hiccups when it comes to fraud and things like that. So obviously, extending similar ideas that already exist in the e-commerce marketplaces today, there has got to be a sense of ratings of buyers and sellers in the marketplace. So that brings me to concluding remarks, which is, so we discussed this problem of, a horizon of problems, I should say, and some initial thoughts on solutions to maybe help spur some thought on your side on how we're going to mature the metaverse, how we're going to scale the metaverse, what new problems arise when we scale the metaverse. In reality, none of these problems are easily solved. A geek like me can definitely say that, okay, we can use some computer science and some network engineering methods, but in reality, there's a lot of behavioral science and insights from there that are involved in coming up with really good solutions. We talked about how, those different problem statements, trade use case, actual user social interaction use case, and how to incentivize and facilitate participation of people such that they actually want to jump into the virtual social world. And then, we looked at those two specific use cases, the serendipitous interaction, as well as building that marketplace, in the trading use case. And then finally, we don't know what will be the ultimate solution. There has got to be a magic formula that will be discovered empirically, because this work is, I think, 5 years ahead. So, when we get there, there'll be empirical iterations to try and find the right solution. But before I end, I'd like to point out, please do join our email list by going to our website. And there's also a paper on light fields that we have dropped recently. And please, if that is a topic of interest to you, then please go ahead and download that.
Hey, thank you, DJ. Now, if anyone has any questions, please feel free to come up to the microphone. We have a couple more minutes to answer some of those, if you have any. I know it's been a long day, long week, but okay, well, if there are no questions for now, we can wrap this up. And can we thank our speaker once again?
Thank you.
Thank you.